Oh, good. How are you? Good, good.
All right, morning, hi. So we continue our conversation from where we left off. But before we start, I just wanted to find out if people have any questions with regards to what we did last time we met. I think it was the day before yesterday or something. I don't know if it was yesterday. Any questions? Okay, everything was clear then. So we're looking at file operations essentially, right? And again, you want to think about what we've been talking about so far from the perspective of why you might want to persistently store data, right? Do you want to refer to it months from now? Are you storing it as a backup mechanism just in case you lose a copy of the data that you have elsewhere, for instance, right? So these are things to think about. All right, so today we transition to our discussion of so-called file systems, right? All right, so we introduced this notion of, oh, by the way, can you hear me?
Yes, sir.
Okay, great. Right. So we introduced this notion of logically organizing these ones and zeros, right? So from the perspective of a computer,
Yes, sir.
it perceives everything as ones and zeros. But for us to be able to easily make sense out of what we're calling data, it needs to be logically organized in a certain way. And it turns out that logical design is actually dictated by so-called file systems, right? So your file system, its purpose is essentially to outline exactly how the files are going to be named, how they are going to be logically structured or stored onto a computer system or storage medium, and how they're going to be retrieved, right? So all of these different aspects are dictated by so-called file systems. Right, so your operating system, file system type will determine the extent of the operations to be performed as well. And this is probably something that you might have come across, maybe not, I don't know, right? But so there's usually certain limitations associated with file systems, things like the file size limit. Depending on the type of file system that you decide to use, you might be restricted when it comes to the maximum file size that you can have on a computer system. Now, in most instances, for the most common use case associated with your average user, the limitation with regards to the file size is not so much of an issue, right? Because we know that at any given point in time, it's rarely the case that you find yourself consuming a file that is more than 4 GB in size, for instance. I mean, maybe it could be like really high definition video, right? But still, it's rarely the case that you'd exceed 4 GB or maybe 8 GB, right? So that's fine. But it turns out that some file systems will have a limit associated with the file size. I don't know if I'm making sense here. I'm just going to just to explain something to you, right? What I'm trying to say here is that I'm just going to give you an example of, I guess, an application that, it's not an application really, of an embedded computer system that I use regularly, right? Almost on a daily basis, every week, I suppose, but that's neither here nor there. But the thing with the way this, it's a GoPro actually, the thing with how this thing works, right, is that it generates a file size, a file with a maximum size of let's just say 2 GB, right? Now, what I'm trying to say is, if you, oh, okay, sorry, you'll see. If you look at this file, right, the video file itself is only, I don't know if you can see this, it's less than 20 minutes in length. Now, if this was a movie, this is high definition, by the way, right? I think 1080p or something is the maximum resolution I can record this on. Now, think about this for a second. If this was a movie, your average movie length is like, well, I guess if it's not Lord of the Rings or one of these fantasy movies, it's usually one and a half hours in duration, right? So what we're saying is, in my case, a 1080p file, right? Which is, let's just say 20 minutes duration, I guess. 20 minutes. Size is, let's say 2 GB, right? What I'm trying to say is, your average user, if this was a movie and it was just one contiguous, I guess, video, which is 1.5 hours in duration, you notice that 1.5 hours is going to be 90 minutes, right? 90 minutes. You will notice that let's just do that, right? You notice that, well, I guess this is kind of one of those units. The size would be like 9 GB, right? So if I had a contiguous footage, which was about and I've actually never checked the file system for my GoPro, but if I had contiguous footage, that was 1.5 hours in duration, I would have a file size of about 9 GB. 9 GB turns out for some file systems is too large. It's too large, right? It can't be handled by most of these widely used file systems, right? Usually limitation. Let's do a simple exercise. I'm just going to switch it off. I'm charging it right now, so I'm just going to switch it off to see switch it on, sorry, to see what sort of file system this is, right? I just switched on my GoPro here. And I guess I can Gpart it or something just to see. I'm curious, right? I swear I don't know the file system for my GoPro, but we're just going to check it right now. Where is it? Why can't I see it? I thought I could see it here. It's unfortunate. I can't see it. Why can I not see it? Device. Devices. Oh, there we go. SB. Oh, so it's here. So you notice that it's FAT32, right? And if you look at FAT32 file system or something, if you were to look, oh, there we go, file 32 file size limit. You notice that, this is good. This is 2 terabytes, which is fine, I guess. So limit for FAT32 is like 2 terabytes. So I can have a contiguous, I can have files that are up to 2 terabytes in size. So one file can be as large as 2 terabytes in size. But if it was a different type of file system, like I think I have some random examples here, like where are we? Like if it was ext, for instance, it would not be possible for me to have. It would not be possible for my GoPro to be able to create a file size with 9 GB. Right, a file with the size of 9 GB. So limitation in sizes, right? Don't know if it makes sense here. That's nice. All right, so it turns out that there's a broad spectrum of so-called file systems, right? And we'll soon understand why. Because different users use computer systems for different things. Right? There are people out there that are video editors, for instance, so they will probably handle massive amounts of files, right? As in large files. Your typical secretary perhaps will just be there to check Facebook and type memos. These are usually small files, right? These are all different use cases that might warrant the use of a particular type of file system. If you spend time online looking up the different characteristics associated with file systems, you notice that some file systems are specific for scenarios where you frequently access data on the file system. Some are more appropriate for instances where you rarely access data. So perhaps all you're interested in is just to dump files or archive files, and then that's it. The next time you're going to access you're going to access the data is probably years into the future or something, right? It turns out that the specific file system is for that.
Sir,
Yes, sir.
sir, does the file system also go with the space, the internal storage of the personal computer, or the file system can be 1 TB and the personal computer can be at any capacity?
No, but your capacity is tied to the file system. The thing we are calling a file system here is, so if you're referring to the storage, before you use the storage on your computer, what you have to do is you need to format it using a specified file system, right? So you're talking about two different things here. So if I'll give you an example of I don't, can you rephrase your question? I mean, maybe I'm not getting your point here. We're talking about different things.
Yeah. Is it possible to have a file system that is as large as 1 TB and a storage that is less?
No, but the storage is associated with the file system. So that question is a bit confusing.
All right.
Storage is associated with a file system. Typically, before you use storage, you need to specify the file system that you're going to associate to that storage, right? This is the process you go through when you're formatting. You purchase a new storage medium, for instance, new thumb drive. And one option you have is you can format it, right? As you're formatting it, you specify the file system you want to associate to it. So size has nothing to do with the file system per se, right? You can have like a 2 terabyte hard disk, right? And you can associate whatever file system you want. So the file system type is agnostic to the capacity of the storage device you want to use, if that was your question. You have to think about this from perspective of why file systems are there in the first place, right? They would dictate certain key things like how you get to name files, how your files are going to be stored, like logically organized, how you get to retrieve them, right? So two different things to talk about them. This is exactly what we're saying here. The fact that the choice of the file system will generally depend on the type of data that you're going to be storing on the file system. So things like the size, for instance, and the relative workload, right? So workload from the perspective of how frequently you're going to be accessing the data. Because it turns out that when you're frequently accessing the data, it could be that you are frequently accessing it so that you just read the information, or it could be that you're frequently accessing the file system so that you perform a number of write operations. So maybe the file system might be associated with some storage medium where you constantly are writing things to that particular file system, right? Frequently writing things to that file system. Turns out that you need a specific type of file system. So things like the anticipated maximum size of files that are going to be stored on that file system. So for instance, if you are a video editor, you know that at any given point in time, you probably find yourself working with really large files. This is something to think about, right? If you're just a student who just writes assignments and, well, I guess you'd be downloading movies, you probably wouldn't have to care so much about the file system type. Going with the default is fine. And in fact, if you bothered to look at this, if you haven't, I do encourage you to do this. What you realize is that when you are setting up an operating system, there's usually default file system type that is selected for you on your behalf when you're installing an operating system for the first time. So for Linux, it's usually ext4, right? For Ubuntu, it's usually ext4. For Windows, last time I played around with Windows, it was NTFS, right? So that is selected for you by default. But if you know exactly what you're doing, what you can do is you can change the file system type to use. And it's easy. It's easy because when you're installing a new operating system, for instance, what you tend to do is you tend to, I don't know if you figured this out, but you tend to optionally format the storage medium before you can install the operating system. So the formatting process will just trying to see if I can connect the thumb drive here. It doesn't look like it's working, sadly. Just trying to see if we could, not working. If we could showcase some random, it's not working, is it? Oh, Lord. Okay. That's weird. I wonder if this has anything to do with okay, nothing. That's unfortunate. I thought this would work though. How about that? Nothing. Okay, that's unfortunate. I thought this would work, but it appears it's not going to work. Can't seem to mount my thumb drive. But anyways, so if you know what you're doing, you get to decide which type of file system you can use. And there's a range of file systems out there, right? You can gain a sense of the types of file systems that are available out there by if we just switch to my GoPro here, and then if I say I want to let me see if I can let me see if I can format this. Can I? New. So I won't effect this change, but you notice if I try and create a new partition on my micro SD card, my GoPro right now, you notice that part of what this utility software tool called gparted does is it allows me to specify, as I'm creating a new partition on the storage medium itself, it allows me to specify the file system I want to associate with the partition itself. Notice by default, ext4 is selected for me. I don't know if you can see this where my mouse is here, but there's a broad spectrum of file system types here, right? ext2, ext3, ext4, FAT16, FAT32, HFS, a whole bunch of them. Some of these things I haven't used before myself. NTFS, which is perhaps one of the most widely used file systems. And really, if you feel like being adventurous enough to kind of look up these file systems, I do encourage you to go to a Wikipedia page called file systems. And then somewhere there should be a hyperlink to list of file systems. There's a really nice list of file systems, There's a very nice, and I guess we do comparison, very nice comparison of file systems. And you notice that the table that you have access to lists a whole bunch of file system types, right? You see these things here? All of these are the different types of file systems that are there. And I'm sure there's one table that has a really nice, there we go. This is what I was color-coded, very color-coded matrix that shows you things like, are you able to see the timestamp associated with creation date or something, last access date, right? I don't know if you remember these metadata elements. I did mention that there are some metadata elements that might not necessarily be available. I said certain operating systems, but it turns out that one way of looking at these metadata elements would be from the perspective of file systems, actually, right? So a whole bunch of them. If you feel like being adventurous, I do encourage you to go here and just poke around these different types of file systems. And in fact, if I were you, right, I'll download the utility software too, and then experiment with different file systems by using some thumb drive that doesn't have important information. You format it using different types of file systems, and then you experiment with the different behaviors of file systems. Why do people, Jesus, not listen here? I do encourage you to go there. Right. So, I mean,
Dr. Lighton on the same file systems.
Yes.
So do you have a case where the operating system would suggest a file system which it will be comfortable with, or whichever type of operating system?
There's nothing like a file system that an operating system is comfortable with. Well, what do you mean by comfortable with?
For example, if you are using Linux and then or when installing it, it suggests, for example, you say that it will suggest ext4, and then you format it with NTFS. There will be no issues when booting or using the system.
No.
Oh, okay.
No issue. No issues. But if you don't know what you're doing, you're better off working with. You're better off working with the default, right? So this idea that you just raised, right? The idea of NTFS. You notice something very peculiar here about the path limit. You notice this value, 32,767 characters. What this means is that if you format your file system with NTFS, if you decide to use the NTFS file system type, there's certain limitations, right? Specifically, the path limit is you're going to be limited to 32,767 characters in your path, your file path. Do you understand this? File path, remember file path, relative path, absolute path, we talked about this, right? Observe, and we said at some stage that that your typical file path is this, right? If you decide to use NTFS, right? Go use it, by the way. If you decide to use it, you will have this limitation on the file path, meaning that these characters in this file path, the characters is 1, 2. Actually, we can count these, I guess. Show it count. I currently have 75 characters in this file path. Yeah. What this means, if I use NTFS, I cannot have a file path that will have more than 32,767 characters. Now I know what you're thinking, right? You're like, well, but in what instances would I want to have a file path with more than 32,767 characters? Well, they could be. There could be use cases. Maybe you are one of those crazy people who names their files, their file names with very long words. Now, like you have a folder called this is my long file name, which enables me to remember why I created this folder. Now, if you're one of those crazy people, right? Now, I'm crazy now, I suppose. You start creating your folders like this, it will create this for you. But you notice that if you have more things within this folder, right? Let's say, just hypothetically speaking, actually, let's do an experiment here. Hypothetically speaking, let's say you have 100 nested directories within this folder, and your folder names are this long, right? Your average folder name has 76 characters. What this means is that the nested directories within that assuming you have folder names that on average have 76 characters, it will be limited to 32,600 and what is this? 32,767. 32,767 divided by 76 characters. So you can only have a total of 431 directories, right? Nested within that. So nested directories within the directory we've created. Do you understand what I mean? Observe, maybe if you don't understand, I'm just going to go to the dir and then you just delete everything in here. It's confusing. Let's say, you, oh, I don't know. Let's do an experiment. So let's say we want to create a crazy directory hierarchical structure which has 1,000 nested directories within our dir example, right? So let's for dir in, just forget about it. Don't worry, just play along here. Sequence 1 to maybe 1,000, right? Do echo, no, start with I guess 10 for now. Do echo dir done. Okay. Do, right? Okay. So I'm going to say make the directory there, and then I'm going to cd into dir, right? And then I'm going to create 1,000 nested directories into here. So here we are, right? Crazy directory structure. We'll create it, right? Oh, I should have just canceled this. Sorry. Oh my goodness. Yeah. I'll just delete this again.
Sir,
Yes.
so is it even possible, even if NTFS has that limit of 32,000, is it possible to make a file path that's actually to that long? Seriously.
Well, yes, it is. I mean, theoretically, it is possible. This is what I'm trying to showcase here, right? Observe what I'm doing here. I'm saying let's do this for dir in, sorry, sequence 1 to 10. Do echo dir done or something. Okay, and then I'm going to say we, it's not me, we'll create a directory within here, and then we'll change directory into that directory, right? So here's the thing, right? Let's create an insane directory structure with 1,000 nested directories within here. So we'll have directories nested within a directory 1,000 times, right? So we'll create a directory 1, and then within directory 1, we'll create a directory 2. Within directory 2, we'll create a directory 3, all the way up to directory 999. 999, we'll create directory 1,000. Yeah. Now I know it's probably, it's not, okay. This is a horrible example because it still won't help us. It still won't help us get to this stage. Why? Because anyway, we can count the number of characters. So we're creating directory structures, right? 1,000 times. And you notice that it is possible to create this hierarchy, but then the limitation would be imposed if the directory names were not necessary. So we just created it, right? This is one. We just created this. Oh my goodness. I don't know if you can see this, but this is our directory structure here. You see this home, light on, all the way up to here. Right? Oh my goodness. I don't know if you can see this. We just created our directory structure. Yeah. So, but here's the thing, right? This is a horrible example here because come on, and it's taking time for me to just check the file path here. I'm trying to see if I can. There we go. And what I'm looking for is I'm looking for. I was trying to see if we can. Okay, we'll start from here, right? We'll start from here. Don't worry. We'll start from here. No, here, I guess. All the way up to here, right? Now, this is it's not really one of those nice examples. Why? Why not? Because you know, the name itself, it's not, I mean, it's long, quite all right, but the number of characters, yeah, if you count this number of characters, it's just like, it's just 978 characters. Not the nicest of examples here, right? It is possible, by the way, not the nicest of examples, but what if we appended, actually, maybe if we appended a name there, it might result into something much better. So I'm just going to change directory to my home directory and then change this. By the way, this is the tree structure we have, right? I don't know if you can see this tree structure here. And the tree structure is a bit messed up here because my font size is quite, let's see with the terminal here. Font size for quick application I use, the terminal application I use is a bit messed up, it's too small. So 3D, right? And still, because it's a long hierarchy, I'll just pipe it to more. So you notice that this is a hierarchy we're working with 1, 2, 3, all the way up to down here, right? But it gets even better, right? What if we created just delete everything I have here now. What if we created we ran the same script, but then instead of just naming directory, we will append a long name, right? We will append this to each directory structure. Do you understand? So we'll be creating a directory that's like so. Right, so which is the directory is in this sequence. Okay, I hope this works. I hope so. Each directory name is going to be each thing is going to be each directory that we're creating in here is going to, it's not going to be named by, it's crazy really, but it's not being named using if you can follow through with what's happening here. But we're no longer naming them just by the name itself, but we are prefixing it by, this is my long file name, which, not enable me, but enables me, remember I created this directory. And every time we get into here, we have a directory that is prefixed in the same way. And you notice that maybe by the time we get to 1000, we'll probably have a pretty long file path, right? If we just go into hierarchical structure number 3, you notice that we already have 263 characters. Now, if we went deep into this thing here, I am sure we'll get to a stage where we would start having limitations. Maybe we can try, right? At what stage would we be able to do this? Maybe we can try actually. Okay, can we count how many? I think we can. Can we count how many characters we currently have? If we have 1000 nested directories, we can approximate, yeah? Observe, if I say, shall we count? So this thing here has 76 characters, assuming, right? Prefix has 76 characters. Assuming the name has, it's not one character except it's 1003. So maybe we just average of 2, I guess. Average of 2 characters for those folders 1, 2, 3, all up to 1000. Just average of 2. We just say average of 2, right? Now, if we have 1000 of them, each one of them will have this plus that. Times 1000. Still not yet there. We just have 78,000 characters. Maybe we can stretch this, right? What if we went to 10,000? 780,000. Yes, 10,000 is good, right? Because the limit here is 32,000. Oh, actually, this is good. 32,000. So in fact, I don't know if you're playing along here, but because my file system uses extended, right? Extended partition, version 4 here, ext4, my file system, where I'm creating these folder hierarchies. It uses ext4. Because I'm using ext4, there's no limit to the file path.
Sir.
Yes.
You lost me on the calculation, sir.
What calculation?
When you are counting the characters to 78.
Yeah, I was just
To me, they
approximating.
seem to be lesser than that. Oh,
What do you
oh,
mean they're
to me,
lesser than that? It can't be lesser than that. We're saying the prefix itself has how many characters? 76, right?
oh,
The name, the number of characters for the name ranges from 1 to 3, right? 1 to 3. Why? Because we have a folder like 1, a folder like 10, a folder like 1,000. So we're just getting the average of 2 for the actual name, the incremental number for the folder. So the total is going to be this prefix here plus either a 1 or a 10 or a 20 or a 1,000, right? It's an approximation. And then we have 78. So we're saying each folder name will have an average of 78 characters. But because we have 1,000 of them, we're just multiplying by 1,000 so that we come up with a total of a file path that has an average 78,000 characters. But it's actually much more than this. Why? Because we are not taking into account this file, the separator. The file system path also has this character here, the separator. Each container structure is separated by a /. But where it's not an exact number, it's not an exact science here, it's an approximation, educated guess, something we can explain. We can also be on point if we wanted to, but we're not here to do that. But the key thing to take note here is that if we were using a different file system path, this was not going to be possible. Why? Because, and I wish I could format this, I want to format this.
Excuse me, sir. Are you talking or something? Because we can't get you.
Oh, sorry about that. Can you get me now? You get me now? Okay, great. At what point did you stop hearing me?
When you said you want to format something.
Oh yeah, so I just formatted my 7.5 GB thumb drive, right? I formatted it using gparted. What I'm going to do is I'm just going to refresh the devices and then try and see if I can access it now. I'll yank it out and then plug it back in. We want to check to see if we'll be able to create the same directory structure for NTFS as we did before. So there we go. I have my nicely formatted disk, nothing in here, right? What I'm going to do is I'm going to go into this, right? And then I will create this, I'll attempt to create this same folder structure. Why am I creating this same folder structure? Because if we are saying, it's NTFS, not part 32 anyway. If we're saying NTFS has a limitation of of 32,767 characters in the file path, then we expect this to fail, right? Because we'll have 778,000 characters in the file path. Here's to hoping this works. Maybe it will work. I don't know what type of NTFS file system. And notice it's slowing down, right? Slowing down. Remember that whole notion of the limitation in terms of or the frequency or how frequent you want to access data or something. You notice it's slowing down now. Let's wait and see, right? Here's to hoping this fails. I don't know if you can see this animation that's coming up. We are creating these folders within the same file path, right? Let's try and see if we get up to 1,000. It might take a while, I guess. I had no idea it would take this long. But we're almost halfway through, I suppose. Is this making sense to us? We're waiting for this to think. Is this making sense?
Oh, yes, sir.
Yeah. Right, so the key takeaway point here is if there's one thing you want to take away from the slide we're on right now, it's that the use of a file system, as with most things now when it comes to computers, is contextual. Down from the type of computer system, now it's file system type. It depends on why you want to use that file system in the first place. What sort of data are you going to be dumping on that particular storage medium that you formatted using NTFS, or that you've formatted using FAT32 or FAT16 or EXT or EXT2, EXT3, EXT4, right? I do apologize, this is taking quite a while here, which is quite sad, but I want us to see if there will be an error, right? We expect there to be an error. Why? Because NTFS is limited to 32,000 I don't know, 32,600 and something, right? 32,767 characters. I don't know why 600 is coming to my head. It's taking a while here. Anyway, we'll check back on it later on. Hopefully we'll find an error afterwards. I'll let it run in the background because we haven't even gone halfway through here. We are creating folder number 462. 462 would give us, let's look at the limit where we'll be able to get the 32,000. 500, maybe 500. Let's wait. Hope it fails. Please fail. If we get somewhere around 500, it should be able to fail because we'll have roughly, or somewhere in the 500s anyway, if our calculations are correct. Sorry about that. I don't know who's sending messages here. Any random questions as well, waiting for this to fail, right? It's an experiment. Let's wait for this to fail. Hopefully it does fail. Any questions with regards to file systems? Hopefully you now know what sort of file system to, if you have one of those funny Android devices where you're funny now because the world has changed, right? Where you can slot in a micro SD card. What you should now consciously think about is what sort of file system should I format it with, right? Because Android does allow you to specify the file system type to use. Yeah, so these are things to think about here. I'm wondering why it's still working when I was expecting it not to work. Anyway, maybe, I don't know. It appears it's still working. I don't know why, but I don't know at what stage it would fail. I was expecting it to fail at somewhere in the 500s. But of course, I mean, maybe again, the thing we've done here is, I was expecting it to fail by then, but anyway, maybe it won't fail. You can always wait for it. We'll check back on it before we end class anyway. All right, but key takeaway point here is these limitations, right? Perhaps the most important limitation, because nobody would be crazy enough to create a file path or have a file path that, I guess there are use cases, but very few use cases where you have a file path that has this number of characters that goes beyond here. But the thing that might apply to the vast majority of people is the size of the files you're working with. I don't know if you've experienced this before, right? Where you have the thumb drive that is maybe 7 or maybe it's 16 GB in size, right? And then someone shares with you a large movie file, right? That is maybe a high definition movie that is, say, perhaps 8 GB in size. And then you try to copy it to your thumb drive and you fail, right? You start thinking, scratching your head, thinking that maybe there's something wrong with your thumb drive. But it turns out that the problem could be that your file system or the thumb drive is formatted with a file system that has a limitation. So for instance, if you format it with, most thumb drives will usually be formatted with FAT32. If you try and dump a file that is beyond 4 GB in size, it will not go in. It will fail, right? And if you're not tech savvy enough to be able to easily interpret the errors that pop up, then you'll be sitting there thinking that there's something wrong with your thumb drive. But in actual fact, the solution would be as simple as just you using a utility software tool to reformat the thumb drive so that it uses a file system that would allow you to dump, let's say, 8 GB, a movie file that is 8 GB in size or something. It's saying I was expecting it to fail. Anyway, it doesn't matter. Maybe NTFS limitation has changed. File path. Yeah, maybe. NTFS, file path limit. Oh, it's not 32, it's 65. Boo-hoo, right? I'll have to change this. I'll change the slides. Not that it matters, but it's supposed to be 67,000. It's supposed to be 65,535 characters. So I will change it later on. So we expect it to fail. Maybe it will fail somewhere close to the 700, maybe 800 mark or something. I don't know. We can always wait for it. I thought. I'm sure it will fail. Do you understand this? But there's other limitations, like the name, right? The name cannot have more than 255 characters. The name of your file. Oh, NTFS is it characters or bytes? Let me just confirm here. NTFS name limit. Just confirm here. The slide's a bit iffy here. Okay, it's 255 characters, which is just fine. Hoping that this solution here kind of makes sense here. Are we together, by the way? I think so. So if it's 255 characters, what we're saying here is how many A, B, C, D up to Z characters. What we're saying is A, B, C, D, E, F, J, K, L, M, N, O, P, Q, R, S, T, U. All right, so what we're saying is that how many 26s do we have in 255? 9 times. So what I'll do, observe, I'll create a funny path which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 260 characters of the alphabet. I want to create a folder. Wait for that to finish. We're going to go to our experiment again, into dir, create a folder. See this error here? Can you see this?
Yes.
Yeah, so because of the limitation, the 255 characters limitation, I cannot create a folder with 260 characters. But what I can do, guys, is I can create a folder with 20, I guess it's a bit 26 times 9. I can create a folder by removing the 26 alphabet characters here, because this will have 234 characters. Can you see this at the bottom here? 234, 234 here. Don't know if you can see where my mouse is here. The first one refused, but now I can create this and it will work. I've created a long folder, right? Which has 200 and, I don't know, which has 200 and 34 characters, but I can't go beyond 255 characters, right? So these are like limitations that you have to be aware of, depending on, this thing is not failing, please fail, depending on what sort of file system you're working with, right? What you immediately realize here is that, so here's an interesting thing here. You soon learn that, I did mention that one character is like 1 byte long. So if you are like Lighton, or if you are like one of those weird people who wants to create a file, a folder with more characters. How many characters do we have here? View, word count, 702 characters, right? These 702 characters. If I try and create these 702 characters onto my, come on, things are not working out for us, are they? If I try and create this, it will fail, right? Why is it failing? Because, where am I? Actually, I'm lost now. Because, and I was trying to see if ext4 is actually bytes or characters. Yeah, I'd have to confirm here. I wanted us to do an experiment where we are working with bytes and not characters, right? Because this thing here is, you know, I know it's ext4 because I checked this in gparted or something, gparted. Like that. Let's see. Okay, ext4. I want us to check ext4 on name limit. Okay, so ext4 is 255 characters, right? What about, I have to change these things here. So ext4 here, it's not bytes, it's supposed to be 255 characters here. Let's see, ext, file system, file name. I'm trying to find something that has a limitation that we can work with. Bytes, super. What are the practical limitations for? I'm trying to find, because if you're working with bytes, right, ext, where's ext here? ext2, ext4. Because if you're working with bytes, if you remember what I said a character is 1 byte long, right? It's 8 bits. And so if we were to attempt to create, a file that fails on ext4 onto an ext formatted storage medium, it would work, right? Because the limitation there is 255 bytes and not characters, you know. But anyways, it's neither here nor there. Okay, so right, so this is just an illustration, something I was talking about in terms of like this sort of limitation associated with the file size. So in this screenshot here, we had a thumb drive that was formatted using FAT32. Remember, FAT32 has a size that is a file size limited to 4 GB. And what we're trying to do here is to move a file that was relatively much larger, right? So this is the sort of error that we got here. File too large, right? And it fails. So these are things to think about. I think this virtual appliance here was, I think, probably about 8 GB in size or something, close to 8 GB, which is why it was failing. Unfortunately, I paged it from my computer because I was running out of space. But if I do find it, perhaps we can do a sample walkthrough when we meet on Monday to showcase to you exactly how this gets to fail. Right? And really, if you look at the errors that application software tools like rsync will give you here, it's not too intuitive, right? When you see this error message, file too large, you'll be sitting there scratching your head. Could this be that I don't have enough space on my USB stick, right? But now you know that file too large could actually mean that there's a limitation associated with the file system. in which case you change codes, and this thing is, I don't know if it's still slowing down, but it's still going strong here. Is this making sense?
Yes, sir.
Oh yeah, right. I thought so too. Let's see if we can. Yeah, let's do file manager before pathways. All right. So it turns out, right, for you to be able to interact with files and folders on your file system, there's software, computer software, specific or dedicated type of software that you should use. So enter the world of file managers, right? Typically, end users, specifically human beings, who interact with the file system using file managers. And there's a whole bunch of them out there. We talked about Midnight Commander the other day. We talked about Google's Files. I've been talking about Dolphin a lot because I use Kubuntu. I like Dolphin because I've been using it for a long time, I suppose. On Windows, you have, I don't know if they still call it Windows File Explorer. Maybe it has a different name here. But this is a software that you use to interact with your file system. And what do we mean by interacting with your file system? It's performing those operations that we had a discussion about. Creating new files, reading files, right? You do that using a file manager. Typically, an operating system will come bundled with a file manager. Why do you think an operating system would come bundled with a file manager? I mean, it certainly doesn't come bundled with what sort of application can I give here? No, I guess it doesn't come bundled. I don't know what else to do. It doesn't come bundled with video recording software, right? Screencast recording software. Why would it come bundled with a file manager? Any thoughts?
Since you explained to us that everything is perceived as a file, meaning we need to have a file manager in order to access those different things that have been perceived as a file on the computer system.
Actually, a better way of looking at this is one of the core functions of an operating system is file management. If that's a core function, there has to be a way of managing files, right? File manager. All right. Right, so typically a file manager will come bundled with a GUI or graphical user interface. So this is what you use to interact with a file system, right? Very nifty features. You can right click, you can work with menu items, right? All the good stuff, and be able to delete files, create files and folders, move files around, right? Drag and drop, all those features that are inbuilt in file managers. Right, so functionalities obviously can be applied to individual files and directories, right? And by the way, these examples here I'm giving here, this was Kubuntu, but this is File Manager on Windows 10, right? Is it File Explorer? I think it's called File Explorer. You see the name here, Windows 10, right? So interface is pretty much the same if you look at it. Might look different, but the basic features are the same, right? You have breadcrumbs somewhere on top here to know exactly where on the file system you're located, right? Because you can have files nested within directories and subdirectories, and so you need a way to be able to backtrack to where it is you want to go back to. So you have breadcrumbs, you have functionalities or features that allow you to find files, so you can search for files, you can preview files, right? You can selectively browse files created on a specific time period, right? So files that I created yesterday, for instance, or last month, right? All the good stuff. Right, so again, I guess this is pretty much the same, but it was just changing, we're just highlighting different different features. This is feature specific to File Explorer on Windows 10 here, right? Where you see these different operations that you have, right? You can copy files, you can paste, you can copy a path, you can move a file. Oh, we have moved to here, which is good. So there's a move operation on Windows. We don't have a move operation on Ubuntu, right? You can check properties. You can do other weird things here, like zip files, for instance, right? These are all features that are inbuilt within your file manager, at least on Windows in this case. You can change the preferences, right? Whether you want the appearance of your files to be small, right? Whether you want to have you want to view more details associated to the file, like the size and the last modified date, all these different preferences that you might be interested in. All right. Any random, I hope this has failed here. This is still working, which is a bit strange. I had hoped it would fail, but it appears it's still working. I don't know why. Any questions, by the way? We'll continue with our case study, which I think we should be able to finish. Oh, I don't know. We'll continue with our case study next week. I don't know if people have any specific questions with regards to what we looked at today. Are you still there?
Yes, sir.
Yes, sir.
Okay. Okay. If there are no questions, then okay. If there are no questions, thank you very much. Cheerio. See you when you see me, which is very, very soon. Also, I'll send out an announcement. We have a quiz next week on Friday, so brace yourselves. Quiz will be based on that'll be input-output subsystem, which you haven't written a quiz in. So please prepare. I'll send out notification. So 7 days from now, I'll have a quiz. All right. I do apologize that this demonstration seems to have failed. I'd have really loved it if it did work. If you feel like sticking around to watch this, I will move out of my chair now and say bye-bye, but I'll let it roll with the hope that it will fail eventually, right? But I won't be around to respond to this because I'm stepping out of my workstation right now. But you're welcome to watch this and see if it will fail by the time it gets to 1,000, right? Because you still have, I think, about 100 or so more directories to create, which hopefully should be able to. Why isn't this fading? Which hopefully should be able to get us to a stage where it fails or something. It's 79 characters. Why isn't it fading? 79 times 1,000. $77 times 1,000. Okay. So you're welcome to stick around if you wish. Thank you. See you when you see me. I'll disconnect this as soon as the script finishes running. Thanks. Bye-bye.
Bye, sir. Oof. 885, 886, 887. Oh, 86, 888, 889. Oh, by the way, Patrick.
Yes, Leandro.
Are we going to have a discussion? And plus, you guys have not given any link regarding the recording of last discussion. Maybe I can just download it. How much space is it? How much? What's the size of last time's meeting?
Oh, you can confirm from Mr. Austin who created the link.
Oh, then we are kindly asking for the link to his drive, so that maybe if it's 60 MB or 70 MB can be sent. But if it goes to 119, like the one we did before the test, that one was too large to be sent. So are we going to have another discussion, or it all ends there?
I'm not sure. It's the people. I think it's the people who decide for now.
All
Because
right.
there are always there are some studies that are being done. So unless uh, after learning, if there's anything that we have to revise, that's when we can schedule a meeting. But as at now,
Oh,
people
so
are
we're not.
trying to prepare.
All right, right. All right, then I won't be sticking around to see when we get to 1,000. Good day. Good luck. May God bless you. Bye.
All right, this experiment looks like it's failing. We'll have to look more into this. Interested in knowing why it's still working up to this point in time, because our file path is it actually does go beyond. Maybe the file path has somewhat changed for ext4 file path. I don't even remember if I'm creating this, if we're creating this path on the USB stick or don't know, on the. Anyway, I'm going to disconnect now. Looks like it did work. I don't know where we are at right now, but I hope this is. Ooh, where are we? I don't know if we are on the, what the hell? I don't know if we are on the, what is this? The click is gone. I don't know if we are, we are still on, the, it's gone. If we are still on the, we're in here. Seems to have worked, I don't know why. But anyways, I'll look into this. See you, I'm disconnecting now, bye-bye.
Bye, sir.